Hello there, and welcome again to Module 303, Lesson 2. In this module, you will start to write some Aiken code. So the main idea behind this module is that before we jump into smart contract development, you have a solid understanding first about how Aiken works and how to implement helper functions. So a quick reminder here. Before you go through this module, I suggest you to check out the type and variable lesson from the main Aiken documentation. You will need that knowledge to go through this module. So the main topic of this lesson is control flow. And you may ask, what is control flow? Well, it is about the implementation of the logic and condition of your program. Think about this key concept, conditions. If this happened, do this, and if another thing happened, do that. In this module, we will see a lot of features of the Aiken language, but they all fundamentally iterate around the same concept, conditions. The most basic way to handle the logic of your program is with if-else expressions. These are conditions that are established according to truth values. That means Boolean expressions, like those that you see on screen. Let's say, for example, let's say that you have some variable x of type integer and you want to check out if it's greater than 10. If it is, it will return the first string, and if it doesn't, it will return the second string. In this case, it is false that 6 is greater than 10, so it will return the second string, it's lesser than 10. You can implement more complex logic with the else-if keyword. So let's go like this. Let's say again that you have some variable x and you want to check out if x is between some range. So first the program will check if it's greater than 10, it doesn't. Then it will check if it's greater than 5, it's not. So it will return the last string, it's lesser than 5. A second way to handle the logic of your program is with the when is expression. Here, you don't set as a condition a truth value, rather you set as a condition the specific value or the specific form that you want to match. For example, let's say that you have a variable, some number, of type integer, and you want to check out if it has some specific value. Here, the when is expression checks out if it's 0, if it's 1, if it's 2, if it's another number. In this case, it is 2, so it returns the third string. Here's another example. Again, let's say that you have some variable, in this case a list, and you want to check out if it has some specific form. In this case, we want to check out the length of the list. So the when is expression checks out first if it's empty, or if it has one element, or if it has two elements, or if it has more than two elements. And in this case, of course, it has two elements. So again, returns the third string. Another way to handle the logic of your program is with the expect keyword. Here, we expect a specific pattern or form in our program, otherwise it returns an error. Here, I have to point out that it is one pattern, not any other pattern. So for example, let's say that you have some variable of type list of integers, and here we expect that it has the form of one element. Like some value, it doesn't have one element, it has two, it returns an error. Some observation that can improve your understanding of the expect keyword is that we can rewrite it to a when is expression. For example, let's say that you have a variable a and we have on it a when is expression that is applied to some value, and we want to check out that if it has one element. If it has, it returns the element inside of the list, and if it doesn't, it returns the error. So as you may see, the expect keyword is like a syntactic sugar of a pattern of a when is expression. Probably the Aiken maintainers saw that this programming pattern was so common that they wanted to abstract it by creating the expect keyword. A last thing that I want to point out about the expect keyword is that it doesn't perform any operation itself, rather it's about catching some type value or some form. And that value that we catch, we can later use it. So here in this example, we have some value, a variable called some value, that is it is a list with one element, and in this program we expect a list with one element. That element inside of the list, we can later use it in the workflow of your program. In this case, we catch the element inside the list and we perform an if-else expression on it, and finally the program returns that it's lesser than 10. Finally, one thing that is not directly related to control flow, but is a syntactic sugar that you will see often in this module, is the pipe operator. And in short, it is a syntactic sugar of function composition. And what is function composition? Well, let's say that you have two functions. One, it is called double and takes an integer and multiply it by 2, and then you have an increment function. Let's say that you want to apply both functions to some value 2. You can re-express this with the pipe operator, like this. First, here you have a value of 2, and then you apply it to the double function, and the result of it, you take it as input to the increment function with this operator. So that way you have a more simple way to express function composition. Okay, so far so good. But later, when we start to use the pipe operator, it sets an important question. If you have a function that takes 2 arguments, to which one is the pipe operator being applied? To the first one or to the second one? The answer to that question is that by default, the pipe operator takes an input and applies it to the first argument. But you can rearrange the order of the operation by doing a function capturing with the underscore. For example, let's say that you want to pipe a value to a subtraction. In the first example, you take a 4 and you pipe it, and by default, the 4 is placed in as the first argument. But in the second example, when we use an underscore, we capture the value in the second place. And that's it. Well, I hope that you have learned some things, and now that you have more experience with about how Aiken works, I will give you some exercises for you to practice. If we go to the GitLab course and to the PBL Aiken starter repo right here, and if we clone it, we will find a file structure like this one. And inside the validators folder, we will find an exercise file with 11 exercises on it, and each one with their corresponding test case. So your task here is to make the test case pass. You can check it by doing the Aiken check command, and as you will see, all tests fail. Also, you might find useful using the Aiken playground over here. You can paste the exercises and perform the checking on this button. So that's it. And if for some reason you find some exercise difficult or you want to discuss it, go to the Discord server and you will find help. Ciao!